Hello everybody. I am here with the continuation of class 9 physics chapter force and laws of motion. In my previous video we have finished this chapter. So today we are doing the in-text questions. I am beginning with the first in-text questions which are given on page number 118. Page number 118. 118. Page number 118, question number 1. Which of the following has more inertia? A rubber ball and a stone of the same size. A rubber ball and a stone of the same size. Which one will have more inertia? Stone will have more inertia. Reason? Inertia is directly proportional to mass. Since stone has more mass than rubber, stone will have more inertia than rubber ball. B. A bicycle and a train. Of course, the answer is train. Reason is saying more mass, more inertia. C. A 5 rupee coin and a 1 rupee coin, and the answer is 5 rupee coin because it has more mass than 1 rupee coin. Question number 2. In the following example, try to identify the number of times the velocity of the ball changes. Number of times the velocity of the ball changes. A football player kicks a football to another player. Velocity is changed. A football player kicks the football to another player of the same team once. Of his team, who kicks the football towards the goal? Second time the velocity of the ball is changed. So player number 1 kicks to player number 2. Velocity is changed once. Player number 2 then kick this football to the goal post. Velocity has changed 2 times. Then the goalkeeper of the opposite team collects the ball. Number 3. The goalkeeper of the opposite team is collecting the ball, so velocity becomes 0. Then and kicks it towards a player of his team. Number 4. So in this example, in this question, velocity of the ball is changing 4 times. Number 1, player 1 is kicking to player 2. Player 2 is kicking to goal post. Goalkeeper is collecting the ball. Velocity has become 0. Then he is kicking the ball to one of his team members. So 4 times the velocity of the ball is changing. And also identify the agent supplying the force in each case. The agent supplying the force. Player 1, player 2, then in 3 and 4, say goalkeeper. First he is collecting the ball, so goalkeeper has exerted force to stop it. Then he is kicking the ball. So goalkeeper is the agent supplying the force 2 times. Then player 1 and player 2. Question number 3. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Yes. When you vigorously shake any branch of a tree, what happens? Some of its leaves will fall down. Why it is so? This is due to Newton's first law of motion. How? When we are shaking the branch of a tree, the trees were at the state of rest and they want to continue in the same state of rest due to inertia. But the direct force is applied on the branch. So you are shaking the branch, but these are the leaves attached to the branch. Leaves want to continue in the same state of rest. So they will remain at rest and they want to continue in the same state of rest. So leaves will resist any change in its position. but the force is applied on the branch. So when you are shaking the branch will get shaken, but the trees will not go along with the branch. Why? Because the leaves are in the state of rest and they want to continue in the same state of rest. So they will remain there only. Due to the direct application of the external force, the branch will get detached from the leaves. So direct force is applied on the branch. So branch is forced to move back and forth, but leaves will remain at rest due to its inertia. So leaves and the branch will get detached and the leaves will fall down. Next question. Why do you fall in the forward direction when a moving bus brakes to a stop and fall backward when it accelerates from rest? I have already explained it in my previous class. Once again, both the reason is same due to Newton's first law of motion. When you are in a moving bus, you are in the state of motion and you want to continue in the same state of motion. When the moving bus is suddenly stopped by applying the brakes, our body will not accept this change. Our body still want to continue in motion due to inertia. So even though bus is stopped by a sudden brake, the passengers are in the state of motion, and due to the inertia of these passengers, they will try to continue in motion. This try to continue in motion is falling forward. At the same time, when you are sitting in a bus and the driver is suddenly driving this bus forward, you fall backward. Reason? In a bus at rest, passengers are also in the state of rest, and the passengers have the tendency to continue in the same state of rest. But when the bus is suddenly moving forward, the passengers will resist this change of state. They want to continue in the previous state of rest. So in order to go back to the state of rest, they will fall backward. I have already explained it while teaching you Newton's first law of motion. Now, page number 126. Page number 126, question number 1. If action is always equal to the reaction, explain how a horse can pull a cart. If action is always equal to reaction, how can a horse pull a cart forward? A very important point to be remembered whenever we talk about action and reaction is that action and reaction are not acting on the same body, but they are acting in two bodies, two different bodies. If action will be on one body, then reaction will be on the second body. Second thing to be remembered is they are acting in the opposite direction. Take this example. A horse can pull a cart. How? Actually, force is pushing the ground backward. That is action. When the horse is pushing the ground backward, the ground is pushing the horse forward. That is reaction. So action is acting on the ground. Reaction is acting on the horse. So when horse pushes the ground backward, which is the action, the ground pushes the horse forward, which is the reaction. When the ground pushes the horse forward, the horse gets the amount of force required to overcome the force of friction of the ground that was acting on the cart. The cart is tied with horse. So when ground is pushing the horse forward, horse now able to move forward because it got the force which is needed to overcome the force of friction exerted by the ground on the cart. So horse and the cart will move forward. Clear? Next question. Explain why is it difficult for a fireman to hold a hose which ejects large amount of water at a high velocity. Again, I have explained it while teaching Newton's third law of motion. Firemen will find it very difficult to hold the hose pipe because that hose pipe is very big in size. So a large amount of water will be flowing out with lot of force. So what happens? The force by which water flows out is action. So what is the reaction? The force exerted by the water on the pipe backward. So this pipe, hose pipe, will move backward with the same force by which the water flows forward. So if you do not hold it tightly, the pipe will get missed or slip from the fireman. So many times two people are involved in holding the hose pipe. Reason, Newton's third law of motion, action, reaction. Due to the reaction, the hose pipe will move backward. So in order to hold it stationary, the fireman needs lot of force to hold it permanently stationary. Next is a numerical. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. A bullet is fired from a rifle. Here this question is all about two bodies, which are the bullet and the rifle. So let us take, so this is question number 3. Given mass of the rifle, let us take it as M1. Here the first body is rifle and mass of the rifle is given, mass of the rifle 4 kg. So M1 equal to 4 kg. Mass of the bullet, which is M2, is equal to 50 gram, is equal to 0.05 kg. Both must be in kg. Bullet is fired with an initial velocity of 35 meter per second. Even though initial velocity is mentioned in this question, it is not actually initial velocity. Initial velocity in this case is 0. Why? This is the case of law of conservation of momentum. Whenever a bullet is fired from a gun, the total momenta of the two bodies before firing, here firing is collision, is equal to total momenta after firing, that is after collision. So when the bullet is not fired from the rifle, both bullet and the rifle has 0 velocity. That is actually initial velocity. So here initial velocity of the rifle, since we have taken it as M1, so it will be taken as U1 is equal to 0. Similarly, initial velocity of the bullet, which is U2, is also 0. So the velocity by which the bullet is fired is not initial, it is final velocity. Given final velocity of the bullet, so what is that? V2. Bullet is taken as the second body. So the Remember this point, the velocity by which the bullet is fired from the rifle is V, not U. Because here action means when the bullet, firing of the bullet. So when the bullet is not fired, no velocity. So both U1 and U2 will be 0. Remember this. The bullet is fired with a velocity, that is final velocity of the bullet. And we are asked to find the final velocity of the gun, that is called recoil velocity. Because final velocity will be acting on the gun in the opposite direction. So it is called recoil velocity. And the recoil velocity of a gun will always have minus sign. Why? This minus sign indicate this velocity is acting in the opposite direction of the velocity of bullet. Bullet moves forward, rifle comes backward. So your recoil velocity will be always minus. Here the velocity of the bullet is given 35 meter per second. 35 meter per second. Final velocity of the rifle, that is V1 is equal to question mark. Now using law of conservation of momentum, M1U1 plus M2U2 is equal to M1V1 plus M2V2. Here U1 is 0, M1 is 4. So 4 into 0 plus 0.05 into 0 is equal to M1 V1. 4 into V1 plus M2 0.05 into 35. 4 into 0, 0, 0 plus 0.5 into 0, 0, 0 plus 0, 0 is equal to 4V1 plus 35 into 5, 175, so 1.75. 4V1 plus 1.75 equal to 0, or 4V1 is equal to 4V1 equal to minus 1.75, V1 is equal to minus 1.75 upon 4 is equal to minus 0.43 meter per second. See this minus sign. This minus sign indicate this velocity is acting in the opposite direction. So it is called recoil velocity of the gun. So the answer, recoil velocity of the gun is equal to minus 0.43 meter per second. So firing a bullet from the gun is an example of law of conservation of momentum. The point to be noted here is that before the bullet is fired, U1 and U2 both will be equal to 0. The velocity by which bullet is fired is not initial, but it is final velocity. Recoil velocity of the gun is also final velocity of the second body. So this is a numerical related to law of conservation of momentum. Is it clear? Okay. Now question number 4. Question number 4 is also a numerical related to the same concept, law of conservation of momentum. Question number 4. And I will read question number 4. Question number 4 is, two objects of masses 100 gram and 200 gram. Let me continue. So given mass of the first body, you may write in full sentence, I am writing only M1. Mass of the first body in bracket M1 is equal to 100 gram is equal to 0.1 kg. Mass of the second body M2 is equal to 200 gram is equal to 0.2 kg. Moving along the same line and direction, same line, same direction, with velocities of 2 meter per second and 1 meter per second. That is, u1 is equal to 2 meter per second and u2 is equal to 1 meter per second, respectively. They collide, and after the collision, the first object moves at a velocity of 1.67 meter per second. So what is that? V1. Final velocity of the first body V1 is 1.67 meter per second. Determine the velocity of the second object. Velocity of the second object, that means V2 is equal to question mark. Very simple question. Whenever you see these things M1, M2, U1, U2, V1, V2, you will automatically get the idea used by law of conservation of momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Substitute the values. 0.1 into 2 plus 0.2 into 1 is equal to 0.1 into 1.67 plus 0.2 into V2. Okay, 0.1 into 2, 0.2. 0.2 into 1, again 0.2. 0.1 into 1.67 is 0.167 plus 0.2 V2. 0.2 plus 0.2, 0.4 is equal to 0.167 plus 0.2 V2. Taking 0.167 to LHS, it becomes 0.4 minus 0.167 is equal to 0.2 V2. 0.4 minus 0.167. This is 0.233. 0.233 is equal to 0.2 V2. Therefore, V2 is equal to 0.233 upon 0.2 is approximately 2.33 upon 2, 1.16. 1.16 meter per second. Clear? It is also a question of law of conservation of momentum. So whenever you read the question, write down what is given in terms of the symbols. Then you will get an idea. This is a question of law of conservation of momentum. Remember this very important formula. M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. Simple application of the values, and we got the answer. V2 is equal to 1.16 meter per second. So the in-text questions of this chapter are over. So please do and practice these questions. In the next video, I will do the exercise questions of this chapter. So thank you for watching me. Please take care of your health, stay at home, but study. Thank you.